All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be doing pretty much a yap sesh. We're just going to be yapping for however long I can. I found the perfect window of opportunity to stream, and I decided to take that. So we are going to be discussing data science and Kaggle related stuff. And I also have this Kaggle notebook open. So in yesterday's stream, I gushed a whole lot about, being able to do stuff in Kaggle notebooks and how I prefer to do data science stuff in Kaggle notebooks versus VS Code locally in VS Code, because locally in VS Code I would have to deal with a bunch of lag, mostly because of my own system. It's not really VS Code's fault, but me doing this through notebooks, it ends up being a lot faster. Like the experience is a lot better. So I prefer to do it in this way. I prefer to do data science stuff through Kaggle notebooks as much as I can. I don't. Okay, so I wonder if I would have the same experience on, let's say, Hugging Face, or which other one was there? I think Replit. I think I would have a pretty decent experience on Replit. But I wonder if I would have a similar experience if I was doing this on Hugging Face. I also wonder if IntelliSense is going to be present there, because IntelliSense it's a huge thing for me. Like before I made up my mind about whether I want to do stuff, through these notebooks, I really had to strongly consider IntelliSense because, dude, it is super helpful. It is an incredibly big time saver. And I'm not just talking about like code completion stuff. I'm talking about stuff like being able to hover over a name and see a description, see the documentation of that class or method or whatever else. Like that's really important for me. It saves a lot of time, because otherwise I would have to look up this information separately each time I had a doubt about, oh, what kinds of arguments does this method take? Or wait, give me a second. We seem to be dropping frames. I think we're good. I think we're good. By the way, I have an update in mind for my VTuber program. I'm thinking I'll build an environment, not necessarily an environment to move around in, but like an environment that kind of creates a theme for the stream. Like I don't know, we could have it where, let's say, we could make it look like there's a desk. On the desk, we have a sort of device that's projecting some kind of hologram, and that the hologram is our, what do you call it? The hologram is basically the screens, these captures that are being displayed here, and of course my own model will be present there as well. I have some ideas for what I want to do. I haven't really solidified any of them. I need to sit down and think about it. But yeah, I'm gonna be working on something for the VTubing app. And I'm also gonna be moving forward with learning VFX graph, or, well, more specifically, learning how to how do I say this? Learning all the different operators and the different blocks and all of that stuff. Because I mean, I know how to use VFX graph. It's more a matter of learning how to put the different blocks that it provides together, learning how to put them together to build complex simulations and different types of VFX and stuff like that. That's what I need to learn, and the only way I'm going to learn that is by building stuff. So yeah, I'm gonna be moving forward with that, and hopefully at some point later I should have an update for my VTuber avatar as well. Yeah, yeah. Okay, so before we get into this, real quick, I have a calculation that I want to do using linear regression. Give me a second. How do I clear this output? Here. Okay. Actually, I could do the entire thing in here. So this is from yesterday's stream, where, or well, yesterday, I guess we can say 12 hours ago stream, I think, where I was trying to what was I doing here? Oh yeah, so I had this data set, this small set of values, and I was trying to plot the the standard deviation and the mean and variance and various other types of I guess we can call them statistical measures onto a scatter plot. And I kind of got stuck at the point where I had to decide what the x of those values was going to be, because for the data set itself, the x was the index of the index of each value. That was the x. Because if I used the y value as both x and y, it would end up being a diagonal line, and that's not really useful, right? But yeah, yeah. I later on when I tried to do the standard deviation and mean and variance, I wasn't able to decide where exactly I should place it on the x-axis, and so I just placed it on 0, I guess, here. Yeah. But yeah, okay. So keeping this aside, real quick, before we get into more data science and Kaggle stuff, there's another data science thing that I've been doing that isn't necessarily related to. Um, I mean, I've been doing research on a different data science related thing, which I just want to test out a calculation. So I'm going to create a set here. Okay. This is going to be, I don't know how many values this is. Let's make this a NumPy array just so I'm able to like get shape and, well, I mean, I could get the length of a list as well, whatever. So, right. I'm going to enter some values here. Okay. This might take a bit because there's a couple of values and I'm testing something out. So I'm just, you know what? I guess I'm just going to read this thing out. So 6429.25, 67364.00, 67425.46, 67,400, 67,374. Okay. Wait, how do I get line, what is it? Line wrapping? What is it? Text wrapping? How do I don't think I've tried, so far I don't think I've tried that. Um, Alt Z is what does it in VS Code, but I don't think that's the case here. Toggle word wrap. There it is. I think. Oh, it's counting this whole thing as one word. Oh, shit. What if we go to the next line? All right, let's carry on. So 6, 7. 232.80 6723. Oh, I'm repeating that. Okay, 67270.68. Then what? 67207.80 67123.08 67224.00 and 67146.03. Okay, right. So, oh God, what is going on? Let's not do that. Let's not do word wrap. What is corgi mode? What is kitty mode? Hold on, dude. Wait. What are these modes? Okay, let's turn on corgi mode. Oh, that's cute. That's cute. I like that. Okay, let's toggle kitty mode. That's also a dog. I expected for kitty mode it would be a cat. Oh, there's a cat as well. Okay. Dude, this is decent. You know what? No, I'm gonna leave this. I'm gonna leave this as it is. Excel font size. Dude, that is so helpful. Hold on. This means that I can zoom out. That is crazy, dude. Yes, that is okay. Okay, I'll take that. This means that I can zoom out because like previously I wasn't zooming out because the thing would become too small. But this means that I can zoom out. Is this too big though? I wonder if this is too big. Okay, hold on. Let's do this and this. Dude, you know what? This gives me some ideas for this is so I wanted to do something similar to this for my VTuber app as well and just have, some robots flying around the screen, maybe up or down or whatever, but they would be representing the chat or people in the chat, right? Maybe I could just make initial one or two uh robots that would move around. Yeah, I could have something like this. This is nice. It's nice to look at. Okay. Um so what was I gonna do? Right. So print a dot, where's the IntelliSense? No IntelliSense? Okay. A dot. Oh, is it because I haven't run NumPy? Oh, this thing would have failed if I wait, no, it did run NumPy. Or not run NumPy. It did run the line in which NumPy is imported. Also, look at this. See, this appeared now that I zoomed out. There's a couple of things that kind of they get pushed they get kind of collapsed when you zoom in, and I usually have to zoom in because of the text size because my screen is kind of far away from me. But this helps, dude. If I could like fine tune the font size, that would be a lot more. Oh God, I don't know what that's gonna open. I have no idea. Hold on. We're gonna switch to BRB. Okay, and then I'm gonna open up whatever this was gonna open up. So it's the theme window, and oh God, wow. So this jumped into my settings window. You've got to be kidding me. I need to be careful with this, dude. Holy shit. Okay, okay. Um, theme is it's mainly doing dark theme. Yeah. Okay. See, this is one of the reasons why I'm always kind of iffy about having about using the main window, the main browser window, because, or rather, this is why I'm iffy about using websites that I'm logged into on stream. Okay, all right. I'm glad that I suddenly panicked and stopped that from loading. But okay, so okay, if I zoom out further, right, it shows that we can we can collapse that further, and the code is visible, the output is also visible, and this still gives us a lot of real estate, so to speak. And also oh dude, this is actually really convenient. This it sort of zoomed out the result of it zoomed out the, what do you call it, the chart, the graph. Yeah, I think I'm gonna use this for sure. um what was I doing? Yes, I was supposed to go and run this thing. So after running this, I'm expecting IntelliSense to work. Okay, yes, it does. Great. So I want to print out the shape. So this is 15 values. Now what I want to do here is create, what is, okay, the model. So I'm going to plot a linear regression uh, thing. I'm how do I, how am I supposed to say that? Basically, I'm gonna use linear regression to find the line of best fit in this data set, and I'm gonna plot that. Okay, so model equals linear regression. Let's see if IntelliSense. Yes, IntelliSense is working, and this works as well. This is why I'm. Oh, I just realized this might be a little bit of an issue. What if I zoom in? So we zoom in here, and did that change? I don't know if that changed. I don't think that changed. Did that change? Oh yeah, it did. It did change. So the IntelliSense thing is, yeah, especially when I'm trying to do autocomplete, looking at the list, that's going to be a bit small. Now, what if I get rid of this Excel font size? The text is a little too small then. Yeah, no, the text is a little too small and everything seems kind of like, oh, you know what? I also need to do this, the full screen thing. All right, so let's do XL font size and hold on. I need to see you know what? This is not that bad. This is actually not that bad. Because the thing with what do you call it? The thing with IntelliSense, the thing with code completion suggestions is that I'm going to be looking at the list for a couple of seconds. I'm not going to be reading it for too long. I'm just going to find whatever I'm looking for, and then that's that. It's not like I'm reading it for the same amount of time that I'm reading code. When it comes to something like the docs for a class or a method, yeah, I'm probably going to be reading for a bit. But you know what? Even that's not that bad. It's not really that small. I'm still able to read it. So I would need to. It would take a little bit for my eyes to adjust and for my mind in general to adjust to this change. But considering the fact that I'm getting a little more real estate. I think I think it's worth it. Okay, cool. So the idea is I I fit this data to a linear regression model so that it can calculate the line of best fit. And then I visualize that line. That's all I'm trying to do. And then we can move on to something else. So in linear regression, when we call model.fit, it's supposed to be n samples and features, right? It's one feature. It's one feature and n samples. It's one feature and n samples. No, no. Hold on. It's n samples and one feature per sample. Okay. All right. It's n samples and one feature per sample, meaning I would have to reshape this a little bit. Now, NumPy does have a reshape thing, which is great. Let me see if I'm able to use it to... Okay, that's not what I was looking for. Okay, let's print out the shape of that. 115. Oh no, it's supposed to be 15 1. Yeah, I just realized my mistake. It's supposed to be 15 samples and one feature per sample. That's what I'm looking for. Okay, great. So we are going to use that in the model. Reshape 15 1, and then for y we are trying to do... It's 15, right? It's 15, so we just do x for x in range 16. No. If I do 15, it's going to be 0 to 14, which is 15. All right, so the model is fit. And now we just need the... Oh yeah, we also need to plot this data, right? So let's plot the data real quick. Let's do plt.scatter. A for x, no, x is supposed to be... So A is supposed to be y, x is supposed to be our list comprehension. So x for x in range... What is going on with my typing, dude? In range 15. All right, let's plot that. There is an issue. Oh, the issue is this. All right, I think that's... Yeah, I think that's roughly what I was looking at. Okay, and then here we are going to plot the line of best fit, where we are supposed to specify x and then we are calculating y. Okay, dude, this is great. This is actually really great. This thing. Oh shit! I just realized me zooming or well going into full screen mode made it so the cats and dogs are not visible for you guys. They are kind of off screen for you guys. Like if I do this, hold on. Hold on. I'm waiting for the stream to catch up. Yeah, if I do this, then you guys are able to see them. But if I get rid of that, then they kind of get cut off. It's okay. It's yeah, it's fine. Whatever. I'm gonna work on something similar to this to add to the stream. Maybe I can have something like flying around or whatever. Also, maybe I should work on a mechanism to turn that effect off, just in case, because I do record videos using my VTuber avatar as well. Hold on. Are we good? Give me a second. Things seem to have frozen. What's going on here? Things seem to have frozen. Give me a second. All right, so I'm going to do something now just to test this out. I'm going to go into full screen and see if that freezes the VTuber app. No, it doesn't seem to be doing that. I think we're good. I don't know why it froze that other time, but yeah, okay, cool. So we have plotted this, and now to get the line of best fit, dude, I'm glad that I looked deeper into line of best fit and also plotting a line. The like basically the idea behind plotting the line, and I'm glad that I learned about concepts. I took the time to learn about concepts like the slope of a line and the y-intercept. These are very basic things, right? But it's one of those things that I just didn't take the time to learn. And if I did ever learn it back in school, I've forgotten about it. So once I got into data science and I started being reintroduced to these concepts and I started relearning them, that's when it really clicked exactly what these things were. And I'm glad that I took the time to learn these things because it has been super helpful. For example, for plotting the line of best, well, okay, you know what? No, hold on. So I could technically, yeah, actually I could, I also realized this thing, I think a couple of weeks ago, that if I pass in, because like when we are calculating, and I'm okay, this brings me back to being glad about knowing how to calculate the fucking line. Um, because of that, I was able to realize that yes, the model is going to be fitting. It's going to be plotting. It's going to be plotting that entire. Okay, I don't know if I'm explaining this very well, but okay. For plotting a line or for finding the y position on the graph, we do mx plus b, right? M is the intercept. No, m is the slope. X is the x value on the graph, and b is the y intercept. The y intercept is basically it tells you what the what the y value will be if x was 0. Is that right? Did I say that right? Y-intercept. Yeah, yeah. It tells you what the y value will be if x is 0. Right. So y equals mx plus b, right? I realized that when we call model dot, I think it's predict. Yeah. When we call model dot predict and we pass in x values, it uses the coefficients and the intercepts that it already has in the model, because that's the whole idea behind the line of best fit, right? It stores these coefficients and intercepts, and then it uses them to calculate a value somewhere on that line. Because the value is being calculated somewhere on that line, you could plot that entire line just by passing a linear range of values in. So I could pass in something like x for x in range 20, and that's going to give me, okay, so let's say res, right? These are the y values, right? So let's write here y, and then we can do plt.line, no, plt.plot. Plt.plot, what are we trying to apply this to? We want the x to be the indices, right? And we want the y to be that. Okay, so then we just pass this in and it's gonna, oh, no, it didn't Ex- oh, hold on, hold on. What is this expecting? It's expecting n samples, right? Wait, what did I do wrong here? Uh, expected 2D array. Oh, oh, okay. All right. Right. So, how do we go about this? Let's say test X, and then we create this, and then we reshape it. So let's create an array and store the list into that, and then we reshape the thing to be 15, 1. Right, and then we pass in test X. Oh, 21. That's not right. That is not right. Hold on, dude. Oh fuck! I missed the add timer. I got so deep into this thing that I missed it. Okay. Uh, hold on a second. The ad break is going to be starting in a bit, and then I'm going to take a hydration break, and then we're also going to look at what went wrong here. Because okay, the points are plotted here. The line is plotted here. Is that the issue? What are the line values? What is Oh, you know what, dude? I don't think I've Wait, are we supposed to pass in normalized data to hold on. What are the values? Let's wait, wrong cell. Oh, also, okay, ad break started, so I'm going to take a hydration break and I'll see you guys in 30 seconds. All right, welcome back. So, uh let's take a look at what went wrong here. Let's print out test X. Oh, yeah. Okay. So, oh, wait. Oh, wait. Hold on. I just realized something. We are mapping massive values to, we are mapping massive values to, to values within a range of 0 to 10. I think that's the issue. We are mapping massive values. Um, so one way to go about this would be to scale down these values. I'm wondering if I can find a way to standardize them. Like, okay, what would be a good way to normalize them? Right now, what's coming to my mind is something like softmax, where you essentially scale down these values down to like a fractional range, such that when you sum up all of the values, they add up to one. I could do that. I could do that. Hold on, wait. I could do that. I could do that for both the values. Yeah, yeah. I could do that for both the values, right? Okay, another thing I could do is I could just scale up this. But then that's going to be, no, dude, how do I do this? How do I do this? Cuz so plotting this wasn't an issue. Plotting the initial values wasn't the issue, but the issue that's arising is if you look at the ranges over here, this is what I was talking about. We are trying to map massive values to small values. That's where we are running into an issue, I think, because the result that's being given is a much smaller range compared to this. And wait, we are trying to predict y, right? If we are trying to predict y is the result? Oh, wait, y, no. So I'm wondering why the result is small. Because it's supposed to be returning the y value, not the x value. Why is the result so small? So this is our test. What is res? Res is small. Yeah, that's not something is wrong here. Something is not adding up. Something is definitely off here. Hold on. Let me try asking. Um, Let me try asking Perplexity. What was I gonna ask? Okay, yeah. I'm trying to fit a linear regression model with data that's in the 60,000 range. The predicted result, the predicted results are much smaller in scale. Why is that? Okay, when fitting a linear regression model and observing that the predicted results are much smaller in scale than the actual data, several factors could be contributing to this issue. Here are some potential reasons and solutions. Feature scaling. One common issue is the difference in scales between the independent and dependent variable. If the features have vastly different scales, it can affect the coefficients and the overall predictions. Dude, suddenly I'm glad that I did. Dude, this thing that I'm doing right now, without going into detail of what exactly I'm doing, this thing that I'm doing, I didn't have it planned at all. It's just something that minutes before the stream, I suddenly got curious about it and I decided to plot it because I had seen it being plotted somewhere else and I was trying to do the calculation myself. And because I know how to do linear regression calculation, at least, through scikit-learn, I decided to try and do this myself. And because of that, now I'm getting to learn this thing about linear regression. Okay, normalization and standardization. Scaling the features to a common range, such as 0 to 1, min-max scaling, or to have a mean of 0 and a standard deviation of 1, which is standardization, can help. This is particularly important when using gradient descent based optimization algorithms, as it can speed up the convergence and improve model performance. Okay, coefficients and units. The coefficients in linear regression models are sensitive to the units of the variables involved. Coefficient interpretation. If the coefficients are large due to the scale of the independent variables, hold on. The independent variables here, wait a minute. I think I missed something here. I feel like I missed something here. So y is what we are predicting. No, okay. X is our dependent variable. Y is our independent variable, which could be any number of features, right? So any number of dimensions. In this case, we have one feature. Okay. Y is the independent variable, right? Later on, oh God, dude, I just realized what I did wrong. I think I just realized what I did wrong. Give me a second. I just noticed a hitch in the stream. Let me just make sure we are good. We seem to be doing okay for the most part. Yeah, I think we're good. I mean, we've dropped a couple of frames, but it's not that bad. Okay, I think I realized what I did wrong. It's that um x is supposed to be, I'm not supposed to be passing in x. I'm not supposed to be passing in x. I'm supposed to be passing in, well, no. Okay, hold on. So, okay, we fit, right. Let's visualize this. Okay? These are our independent variables and these are our dependent variables. Wait, did I say that the wrong way? No, I think these are our independent variables and these are our dependent variables, because this is y, right? When we pass in values to the predict method, we are trying to predict y. We are trying to calculate y because we already have x. Right? Now, that being said, should I have switched both of these? Like what I made x, should I have made that y instead? And what I made y, should I have made that x instead? I wanna try that. Let me let me see if that helps. Hold on. So where is A? A is here, A is here as well. Let's change this to, no, let's not change it. So this is supposed to be our sample. No, wait. This is supposed to be our x. Instead of x, what if we pass in y? So let's switch the order here. That's not going to work. No, that's not going to work. It's supposed to be n samples and features, right? Give me a second. I need to look at the... Okay, x and y. Oh, it's not supposed to be part of like one set. Okay, all right. That's okay then. No, no, hold on. X is supposed to be a set. X is supposed to be a set. It's supposed to be n samples and features. Like in shape, it's supposed to be n samples and features. No, let's not do this. So going back to the issue that we are having here, what I was expecting is that I'm going to pass in X and it's going to predict Y. But it doesn't seem to be. Okay, you know what? I think we need to hold on. So this is supposed to be our X. Okay. Um this is supposed to be our X, and this is supposed to be our Y. So we're going to make this also a NumPy array just in case we need to play with the shape later. So X for X in range, what is it, 15? Yeah. Right. So that's our, that doesn't make sense. Oh, damn, dude. Hold on. That doesn't make sense. That does not make sense. So for X, we are trying to predict Y. But then when I plotted the data here, I think I plotted it the wrong way. Yeah, I think the issue is that I plotted the data the wrong way. Maybe it was supposed to be like this. Yeah, I think it was supposed to be like this. And then but that's not how I'm trying to plot this as time series. Right? So X is supposed to be the time and Y is supposed to be the value. However, trying to fit this to the linear regression model, I'm not able to think of a decent way to do this. Because, okay, what if we did this? So we have Y, right? Let's make this Y, and let's make this X. Uh, what are we trying to do here? We have this, and we want to reshape this into. Actually, we can reshape later, right? Okay, we can reshape that later however we need to. So X is supposed to be our dependent variable. And what I'm trying to do here is plot it as a time series kind of thing, right? It's supposed to be that X determines Y. Okay, okay. Yeah, I think I fucked up. I fucked up the way that it's supposed to, like, it's being, the model was fitted in a different way, and I plotted the thing in a different way. And I thought that the plotting that I was doing was representing the way that the model fitted the data. I think that's where I fucked up. Okay, so X is supposed to be our dependent variable. No, X is supposed to be our independent variable. Y is supposed to be our dependent variable. Y is what gets predicted, right? What does, okay, model dot predict. Predict using the linear model, and we are predicting using X. Okay, we are predicting using X. So let's say we are fitting this model. We're gonna redo this whole thing. Okay, so we have Y. You know what? Before any of this, let's plot the data. Let's plot the data with our X and Y. So X is supposed to be this and Y is supposed to be this. We can call predict later on, and for now let's just take a look at the. Okay, so that's what we need. Okay, that is what we need. Now we try to fit the data with, give me a second. Actually, give me a couple of minutes because after I got up, I just realized I need to go use the restroom. So I'm going to switch to BRB and I will BRB in a couple of minutes. All right, I'm back. So let's get back to this. Let's try to figure out what I did wrong here. So x is our dependent variable, and no, x is our independent variable, which we are trying to, which we are using to predict our dependent variable. Is that right? Did I say that right? I think so, right? The dependent variables depend on the independent variables, right? There was a way that I had visualized this in my head to understand the difference between dependent and independent variables, but I seem to be forgetting that. I think yeah, independent variables are the variables can be uh, that can be used to predict the dependent variables. I don't know. I don't remember. I'm gonna have to go back and. Oh, you know what? I could just ask. Wait, no, I don't want to lose that. I don't want to lose that information that um, this this LLM has given me. Okay, okay, hold on. Wait, what is this? Standard scalar pre-processing. Okay, all right. We're gonna get to this. We're gonna get to this. Hold on. First, I want to do this thing that I'm doing. All right, so we scattered the data, and this is what we are looking at. All right, so now we want to fit the data, right? No, we want to fit the model with this data. X is supposed to be our independent variables. Or is it y that's supposed to be? No, y is supposed to be our dependent variables. X is supposed to be our independent variables. All right. Okay. So then we take x and we reshape it. Where is that? Reshape it to be this way, right? And then we just pass in y, which is our dependent variables, or dependent variable. It's one. Yeah, yeah, yeah. Dependent variable. Okay. So we have fit the model with the data, and now we want to pass in. Okay, let's try predicting one value first. Okay, so this is expecting it's expecting this. Okay, so let's do something like that, and then plt.scatter res on. Wait, it's predicting y, right? It's predicting y. So okay, let's place it somewhere in the center. So our data in terms of this plot, let's place it. Actually, let's let's say let's do the exact value that it is. So 5. And then the other thing is res, so we just do that. I don't know if I'm supposed to pass in like array like items or wait. Like will it accept single values? It just says x and y. What if I just pass in single? Okay, whatever. I mean, I can just pass. No, you know what? I'm curious. Let's pass in a single thing here. Also, let's print out res. So this ran and it worked perfectly. Okay, it was my fault. The issue wasn't with linear regression, though this did give me something to do research on because I'm one now I need to do research on how well we are able to map small values to massive values and what's the behavior going to be like there. Because I need to figure out if there's a need for both the dependent and independent variables to be in a common range or not. And if there is a need, then I need to look into standardization. I mean, I'm anyways planning on looking into standardization, but like I need to find out if there is a need. All right, so here now we can pass in Right, so let's do test X. Change this to predict Y. All right, so test X, we do this and we pass in that, and test X. So we get the result, and the result is, right, so the X is going to be the indices of the array, and the Y is going to be the values themselves, right? So now we can just do plot of res. There it is. This is our line of best fit. Okay. Okay. All right. All right. Cool. So I'm starting to get it. There was something else that I was doing research on that that kind of led me to doing this calculation, or mainly just trying to plot the line of best fit given a specific set of data points, a specific set of values. Also, something that ties into the data science stuff that I'm doing is, well, something that's common in the other research that I was doing and the data science research that I'm doing is the concept of time series data. Time series data is basically data that's collected over over like a certain period of time, at certain intervals. So it can be something like weather data, it can be financial data, um, it can be sales data, it can be a bunch of different types of data. But the whole idea there is that it's giving you an idea of what the data is like across a certain time frame, and that's why it's called time series data. And in both data science and deep learning, you do eventually go into time series related operations. And somewhere in between, I'd seen something about time series analysis. I don't remember where exactly I had seen that, but I'm gonna have to revisit that at some point. Okay, so what was this? Oh, I don't think I finished reading this. In between, I just realized that, yeah, I'd fucked something up in my calculation. And that's exactly what happened here, right? I fucked up something in my calculation, and because of, not exactly calculation, I fucked up something in my logic, and because of that, it was coming out weird. The ranges were like very weird. But it's interesting to see that I am actually able to map tiny values to massive values. Because look at this, I'm mapping values that are in the tens to values that are in the 10,000s. And it still seems to work. Because I was confused about why this wouldn't work, because this is supposed to be time series data, right? Time series data isn't necessarily always going to be, how do I put this? The time isn't necessarily always going to be in the same range as the value across that time, right? So in time series data, the x, which is the time, isn't necessarily always going to be within the same range as the y, which is the actual value. And so that's why I was confused. I was like, okay, what are we meant to do in that situation? And my first guess was something like standardization, but then I was like, okay, is it necessary to bring everything into a common range? Let's carry on reading and see. Okay, if the coefficients are large due to the scale of the independent variables, but the dependent variables but the dependent variable is on a much smaller scale. If the coefficients are large, Due to the scale of the independent variable. Okay, so in this case, it's due to the scale of the, uh, well, it's due to the scale of the dependent variable, not the independent variable. But okay, anyways. The predictions might appear small. For example, if you're predicting a variable that is in dollars using features that are in the thousands or millions, the coefficients will be adjusted accordingly. Normalizing or standardizing the variables can make the coefficients more comparable and interpretable. So one, I'm okay. I'm super interested in seeing how standardization can change, or no, more specifically, how softmax can change um, can change the shape of the data. If that makes sense, I don't know if what I just said made sense. Okay, aside from PyTorch, is there any other way that I can like do any other libraries support softmax? I'm sure some other libraries do support softmax. Hold on, sklearn softmax. Okay, SciPy has softmax. sklearn has logistic regression for a multi-class problem. If multi-class is a set, no, if multi-class is set to be multinomial, the softmax function is used to find the predicted probability of each class. Okay, how is it getting softmax? Like how is, so this is logistic regression is in scikit-learn, right? How in scikit-learn, where is it using, or is it just doing the calculation internally? I think it might be doing it internally. The softmax function transforms each element of a collection by computing the exponential of each element divided by the sum of the exponentials of all the elements. That is, if X is a one-dimensional NumPy array, then so and so, so and so, so and so. Okay, let's test that out real quick. Okay, let's open up a new cell here, and let's go up here and do, what is it? Something special. I think scipy.special.softmax. So from scipy.special import softmax. Okay. All right, run that, and we are good to go. Wait, why is there red text there? Okay, no, we're fine. Yeah, here. So A equals, let's say, okay, wait. So let's give these values, okay? And then we want to do softmax of A. Okay, it's that simple. All right, so here's what I want to do. What was the thing with random? Was it np.random.rand is, what does rand take in? I forgot. Random values in a given shape. Oh, okay. Let's use, I think it's random.random. Okay, that's also not what I was looking for. What does rand n give? Nah, that gives us yeah, no, that's not what I'm looking for. Dude, one of these would give integers, right? Was it just called rand int? Oh, it's called randint. Okay. Let's say we want to do um, between 0 and 20. And let's say the size is supposed to be um, 10 samples. What's the other thing? D type int. Okay. Yeah, it's supposed to be int. Okay. And then here we do this exact same thing. And let's plot this on a scatter plot. So PLT scatter A and B. Okay, these are our values. Okay, now what I want to see is if plotting a scatter plot of the softmax of each of these um, is going to have the same effect. Oh shit, it's not doing it on different plots. It's doing it on the same plot. Um, yeah, that's not what I was looking for, because it goes down to this scale, like it gets scaled all the way down, right? So that causes a problem. Okay, let's create a figure and this, and no, what's a good way to do this? So we have plt.subplots, and in here we can give the, okay, so we can do number of rows and number of columns, right? So one row, two columns. Okay, and then how am I doing this? Would it be like this? I think it would be like that. Okay, so then AX1 would be the other one. Okay, no, it does not. It does not look anything like, yeah, no. Scaling it down definitely changes. It changes the pattern. Actually, more specifically, scaling it down with softmax changes the pattern. Though I wonder if we could still capture the relationship between the two variables. Even if the pattern looks different, could we still capture the same relationship um, by using softmax? Though the issue is, how do we scale the softmax back up? Yeah, no, that's not going to work. Let's see what this is suggesting. Model assumptions. Ensure that ensure that the assumptions of linear regression are met, particularly the assumption of linearity and homoscedasticity. Homoscedasticity. That's a word. Holy shit. Linearity. Check if there's a linear relationship between the independent and dependent variables. If not, transformations or nonlinear models might be necessary. Well, in this case, there is a linear relationship, at least considering that, the data set that I have, it was a linear relationship. Kind of? No. Well, I mean, would it be considered a linear relationship if this data was collected? It's time series data, right? And the data has been collected. So, like, okay, We are not trying to predict new values here. We are trying to create a mapping between existing data. So an existing dependent variable and an existing independent variable. So by that logic, it is linear. In a way, it is linear because you know at specific intervals in time, we had those specific values being generated. Okay, homoscedasticity. Ensure that the residuals have constant variance. If the variance changes with the level of uh, if the variance changes with the level of the independent variable, it may affect the accuracy of the predictions. Data transformations. Sometimes transformations can sometimes transforming the data can help in achieving better predictions. Log transformation. If the dependent variable has a large range, consider using a log transformation to stabilize the variance and make the relationship more linear. Log transformation. Okay, so there's two things I need to do research on here. One is log transformation. Hold on. Log transformation. And there was something about variance. Yeah, stabilizing variance. Also, I need to go back to looking into residuals because I forgot what residuals were exactly. I'd looked into it when I was looking into like basic stats stuff. Yeah, I need to refresh my knowledge on residuals. Okay, model complexity. Ensure that the model is not overly simplistic or complex is not overly simplistic or complex for the data. Multiple linear regression. If you're using simple linear regression with a single independent variable, consider adding more relevant variables to improve the model's prediction power. However, be cautious of overfitting. All right. Okay, cool. Here's an example to illustrate the issue. Suppose you're predicting housing prices based on the number of rooms, which is suppose you're predicting housing prices in dollars based on the number of rooms, which is typically a small number. If the coefficients are large to the scale hold on. If the coefficients are large due to the scale difference, the predictions may appear small unless the features and target variable are properly scaled. Unless the features and target variable are properly scaled. Oh, the features are the independent variables and the target is the dependent. Okay. All right. Here we go into pre-processing. Assume X is your feature matrix and Y is your target vector. Scalar dot fit transform X scaled. Okay. Scale to what? What is it scaling to? By scaling the feature, no, the features. By scaling the features, you ensure that the model parameters are more interpretable and the predictions are on the correct scale. In summary, the discrepancy in scale between the predictions. So, okay, I asked Llama this question, and throughout this question, or while reading this answer, I realized that that wasn't the issue. The issue was the way that I was. The issue was in my code logic. So the model was performing perfectly fine. That being said, this has kind of introduced me to a couple of other topics that I need to do research on, which is always a good thing. So there is a pre-processing section here. Let's take a look at that. I think it's under data transformations. Yeah, pre-processing data. Okay. Standardization or mean removal and variance scaling. Standardization of data. Hold on, I need to zoom in. Should we start from the top? Um, oh, they have a thing called normalizers as well. And but I guess I'll also take a look at transformers. Okay, so standardization of datasets is a common requirement for many machine learning estimators implemented in scikit-learn. They might behave badly if the individual features do not more or less look like standard normally distributed data, which is Gaussian with zero mean and unit variance. In practice, we often ignore the shape of the distribution and just transform the data to center it by removing the mean value of each feature. By removing the mean value of each feature. Then scale it by dividing non-constant features by the standard deviation. For instance, many elements used in the objective function of a learning algorithm, such as the RBF kernel or the RBF kernel of support vector machines, or the L1 and L2 that word is always hard to say. Re- regularizers. Okay, regularizers of linear models may assume. Oh, okay. Guys, I need to end the stream.